We're going to solve this system of equations, negative 3x plus y equals negative 5 and 3x minus y equals 5. Now looking at these two equations, you can see that if you add these two equations together using the elimination method, a variable will cancel. When you add these two equations together though, both variables cancel. Now here's a case where you do not panic. So your job is to solve for x and y. You add the two equations together and both variables disappear. Do not panic. It's one of two things. All you have to do is look at what you're left with when the variables disappear. So when we add these together, negative 3x and 3x is 0, negative y is 0, and negative 5 and 5, if you add those together, that's 0. What you look at is what you're left with. We have 0 equals 0. You have to decide, is that true or is that false? If you're left with a true statement, so when the variables disappear and you are left with a true statement, it means you have infinite solutions. That means these two lines are the same. So these two equations are the same. If we graph them, it'd be the same line. There would be an infinite number of intersecting points. So infinite solutions means there are an infinite number of intersecting points. The graphs of the two equations have an infinite number of intersecting points because they are the same line. So the answer to this, if your job is to solve the system of equations and this happens where the variables disappear, just decide, are you left with a true statement or a false statement? 0 equals 0, that's always true. Then, if it's always true, there are infinite solutions, meaning these two lines are the same. They would have an infinite number of intersecting points. And you can see that if you take these two equations and get them in slope-intercept form, what are you going to see about their slope and their y-intercept? They're going to be the same. They're going to have the same slope and same y-intercept. So if we take that first equation, negative 3x plus y equals negative 5, get that in slope-intercept form, add 3x to both sides. You have y equals 3x minus 5. Same thing for the second equation, subtract 3x from each side. You have negative y equals negative 3x plus 5. And again, y equals 3x minus 5. Same thing, same slopes, same y-intercept, same equation. So they are the same line. Therefore, they have an infinite number of solutions. A solution is an intersecting point of the two lines. There are an infinite number here because it's the same line. Let's go back to the beginning. Remember, you can do anything to an equation you want as long as you treat both sides equally. So let's say we took that first equation and multiplied both sides by negative 1. That means you would multiply each term by negative 1. If you did that, negative 1 times negative 3x is 3x. Negative 1 times y is negative y, and negative 1 times negative 5 would be 5. So obviously, those two equations are the same. So if your job is to solve the system of equations, the answer here would be infinite solutions. We're going to solve this system of equations using the elimination method. Notice if you add the 4x and negative 4x, those would cancel. But also if you add the negative 6y and 6y, those would cancel. So once again, you go to solve with the elimination method and both variables disappear. Do not panic. You didn't do anything wrong. Just decide, are you left with a true statement or a false statement? So is 0 equals 16, is that true or false? Because if it's true, like we had on the last one, that's infinite solutions. If it's false, it's something else. Of course, 0 equals 16, that's a false statement. 0 is never going to be equal to 16. So that is a false statement. So when the variable disappears and you are left with a false statement or a statement that is never true, there is no solution. These two lines do not intersect. If you graph these two equations, you would see they're never going to meet. Now think about that. What two lines, what type of lines never meet? Parallel lines. So these two lines are parallel. So once again, when you're going through the elimination method and the variable disappears, both variables disappear, do not panic. Just decide, is it true or false? If you're left with the true statement, it's infinite solutions. If you're left with the false statement, that is no solution. Infinite solutions means it's the same line. No solution means you're dealing with parallel lines. So if we got these in slope-intercept form like we did the last one, what are you going to see about the slope and the y-intercept? What's going to be true? We'll take each of those, get them in slope-intercept form. So that first equation, subtract 4x from each side. You'd have negative 6y equals negative 4x plus 6, and then divide each side by negative 6. Y would equal 2/3 x minus 1. Take the second equation, add 4x to both sides. You have 6y equals 4x plus 10. Divide each side by 6. Y would equal 2/3 x plus 5/3. So if you look at those in slope-intercept form, you can see things more clear. You have the same slope, but different y-intercepts. So think of two lines with the same slope and different y-intercepts. What type of lines are they? Parallel lines. So once again, to repeat, when you're solving a system of equations and the variables disappear, don't panic. Is it true or false? If it's true, there are infinite solutions. If it's false, there is no solutions. Infinite solutions are the same line. No solution are parallel lines. So to answer this, to solve the system of equations, here, that's no solution. A student has some $1 bills and $5 bills in his wallet. He has a total of 15 bills that are worth $47 total. How many of each type of bill does he have? Right there. How many of each type of bill does he have? That's what you're going to let your variables represent. Always let your variables represent what you're looking for, because they are the unknown. So you have two types of bills here. You have $1 bills and $5 bills. You need to know how many of each type. So X is going to equal the number of $1 bills, and Y is going to equal the number of $5 bills. Now you need to make two equations so that you can solve that system of two equations and decide what number of bills there are. So one equation, since he has 15 bills total, X is the number of $1 bills, Y is the number of $5 bills. That means if you take X plus Y, that's going to equal that 15. And then if you include the dollar value, $1 bill, of course, is worth $1, so it would be 1 times X. A $5 bill is worth $5, 5 times Y. That's going to be equal to that total that he has, $47. So I don't have the 1 here, but it's 1 times X plus 5 times Y. That equals 47. So there you have a system of two equations. You can easily solve that system using either the substitution method or the elimination method. It would be your choice. I'm going to take that first equation, x plus y equals 15, so that I want to be able to cancel the x's off. I'm going to multiply that first equation by -1. That becomes negative x minus y equals negative 15. The second equation will stay the same. Leave the second equation the same so that now when I add those, the x's will cancel. So when I do add those two equations, negative x and x, that's 0, it cancels. Negative y plus 5y is 4y, and negative 15 plus 47, that is 32. Just remember, when you're multiplying one of the equations by something, that you multiply each term by something, including that, in this case, 15 after the equal sign. Make sure that's negative 15. Solve that for y, divide each side by 4, y equals 8. So y is 8, that's the number of $5 bills. To get the number of $1 bills, we need to find out what x is. So go back, any equation up here where you see an x and a y, you can substitute 8 in for y and find the value of x. The easiest one to work with is probably this one right here, x plus y equals 15. So substitute 8 in for x, and by the way, you know there's 15 bills, so there's going to be, if there are 8, in this case, 8 $5 bills, you know there's going to be 7 $1 bills because there's 15 total. Anyway, substitute 8 in for y, so it's going to be x plus 8 equals 15. You've got to skip the algebra if you want to. I wouldn't recommend it though. X plus 8 equals 15, subtract 8 from each side, get x equals 7. X is 7, y is 8. So that means, remember x is the number of $1 bills, there are 7 $1 bills and 8 $5 bills. And total those up just to check this. 8 $5 bills, that'd be $40. 7 $1 bills is $7. 40 plus 7 is $47. Don't spend it all in one place. A student took 60 minutes to answer a combination of 20 multiple choice and extended response questions. She took 2 minutes to answer each multiple choice question and 6 minutes to answer each extended response question. Need to do two things here. Need to write a system of equations to model the relationship between the number of multiple choice questions x and the number of extended response questions y. So we need to write a system of equations. I'm going to let x equal the number of multiple choice questions because that says it right there, and y would equal the number of extended response questions. Now, system of equations. She took 60 minutes to answer a combination of 20 multiple choice and extended response questions. So 20 questions total. If x is the number of multiple choice, y is the number of extended response, then one equation would be this, x plus y equals 20. Now let's think about the time. She took 2 minutes for each multiple choice question, so it'd be 2 times x. 6 minutes for each extended response question, so for time it'd be 6 times y. And remember, she took 60 minutes to take the test. So 2 minutes for a multiple choice, 2x, 6 minutes for an extended response, that's 6y. Total minutes is 60. 2x plus 6y equals 60. That's the system of equations we want to use. It says how many of each type of question was on the test. So we need to solve this system of equations for x and y. I'm going to take that first equation, multiply that first equation by -2, because then it will be -2x and 2x. So I'm using the elimination method. You have a -2x and a 2x, the x's will cancel. Just make sure you multiply each term by -2. So I get -2x minus 2y equals -40. Now the bottom equation stays the same because I already have a -2x. The bottom equation will just stay as it is, so that when I add those together, these x's will cancel. So the elimination method, you want to get one of the variables to cancel so you can solve for the other variable. So now adding those two equations together, the x's do cancel. -2y and 6y, if you add those, it's 4y. -40 and 60, that is +20. 4y equals 20, that means y equals 5. Remember, y is the number of extended response questions, so there were 5 extended response questions. We still need to find the number of multiple choice questions. It's not hard to do because there were only 20 questions. So all you'd have to do is take 20 minus 5. Or you can follow along with what we've been doing and substitute in. Y is 5. You can take that, substitute it into any equation up here with an x and a y. The easiest one to substitute into is this one, x plus y equals 20. We know that y is 5, so substitute that 5 in for y. It'd be x plus 5 equals 20. Subtract 5 from each side, as I told you before, x equals 15. So the number of multiple choice questions was x. That's 15. 15 multiple choice. And the number of extended response questions we represented with the y. We found out that y is 5. 5 extended response. So 15 multiple choice, 5 extended response. That's 20 questions total. And that is the answer. Identify and correct the error in finding the solution of the system below using the substitution method. So we have these two equations, 3x minus 4y equals 14, and x plus y equals -7. Someone used the substitution method, and as you can see by my buddy behind me, has made a mistake. So he'll be thrilled when we find the mistake. So these are their steps. Take this x plus y equals -7. That's the first equation. Remember, with the substitution method, we want to get one of these equations to read x equals or y equals. We want to solve one of these equations for x or y. Since the x and y here have no coefficients showing in front of them, we want to get one of those isolated. You want to isolate either the x or the y. So it looks like they're on the right track here. X plus y equals -7. They're taking that second equation, solving that for y by subtracting x from each side. Get y equals -7 minus x. So far, so good. So now that you know y is -7 minus x, take that -7 minus x and substitute that into the other equation for y. So we'll take that first equation, 3x minus 4y equals 14, and we're substituting this -7 minus x in for y. So replacing the y with -7 minus x. Now I think he'll be happy once we get through this next step. On this next step, 3x minus 4 times -7 minus x equals 14. Going to use the distributive property. Watch your signs. -4 times -7 should be a +28. And -4 times -x, that should be a +4x. So whoever did this did not distribute the negative sign through with the 4. So that is the mistake. Should be a +28 and a +4x. So doing this the right way, it's 3x plus 28 plus 4x equals 14. Combine the like terms, 3x and 4x is 7x. It'd be 7x plus 28 equals 14. Continue solving for x. Subtract 28 from each side. Get 7x equals -14, then x equals -2. So now that you know x is -2, you could solve for y. Take that -2, substitute it into any equation up here with an x and a y. You could substitute it in right there, or even this one right here where it already says y equals. So where that already says y equals -7 minus x, I'm going to substitute -2 in for x. It's going to be -7 minus a -2. Don't make the mistake they did. Watch your signs. Minus a negative becomes plus. So it'll be -7 plus 2, and that is going to be -5. So x equals -2, y equals -5. That is the correct solution. At a bookstore, used hardcover books sell for $8 each, and used softcover books sell for $2 each. You purchase 36 used books. That's all the hardcover and softcover books total. 36 used books, and you spend $144. how many softcover books do you buy? Now remember, let the variable represent what you're looking for, what you're trying to find. You don't know how many hardcover books you bought. You don't know how many softcover books you bought. So X is going to be the number of hardcover books. Y is going to equal the number of softcover books. Now we need to make two equations. We're going to solve that system of two equations for X and Y. So one equation would involve the number of books. You purchased 36 books. So X plus Y, the number of hardcover plus the number of softcover, is going to equal 36. The second equation is going to include the prices. Hardcover books sell for $8 each. Softcover books sell for $2 each. So take 8 times X plus 2 times Y. That equals the total money you spent, which is $144. So X plus Y equals 36. 8X plus 2Y equals 144. There's your system of two equations. Now you can use either the substitution method or the elimination method. I'm going to use the elimination method. I'm going to multiply the top equation by -2 so that I have a -2Y and a 2Y. Then when I add those together, the y's will cancel. So make sure you multiply each term of that top equation by -2, including that 36 on the other side. Make sure that's -72. Bottom equation will stay the same. That's still 8x plus 2y equals 144. I'm going to add those two equations together and the y's will cancel. Then I'll have one equation with one variable. I can solve that equation for x. So -2x plus 8x, that is 6x. -72 plus 144, that is 72. 6x equals 72, that means x equals 12. So you bought 12 hardcover books. Still need to find the number of softcover books you bought. It's not hard to do because you purchased 36 total books. So if you purchased 36 and 12 of them are hardcover, then there's going to be 24 softcover. Or you could substitute in, take that 12, substitute it in for x, and any equation up here with an x and a y in it. I'd go with the easy one, x plus y equals 36, put 12 in for x. 12 plus y equals 36. Then of course, y, like I told you before, is 24. 12 hardcover books and 24 softcover books. Now you would get the same answer if you use the substitution method. If you graph these two equations, they would meet at the point 12, 24. If you use the substitution method, you get the same thing. So there are three methods, elimination, substitution, or by graphing, that you could easily get the answer. Correct answer here. How many softcover books did you buy? You bought 24 softcover books, but one thing to point out, 12 was also an answer. That would be for someone who's not really paying attention. 12 was the number of hardcover books. We wanted the number of softcover books. Correct answer is letter I, 24. Which of the following systems of equations has the solution for -1? There's quite a few ways you could do this. Probably the fastest way is by using a graphing calculator. Graph each system of equations and see which system has a point of intersection of 4, -1. But if you don't have a graphing calculator, you could do the substitution and elimination method for each system. That's if you have a lot of time on your hands, because that's probably going to take the most time. Substitution or elimination method on each one of these systems to see where x equals 4 and y equals -1. Another way it's not so bad, not going to use up so much time, is just by substituting in. Put 4 in for x, -1 in for y, into each equation of each system, and if that makes a true statement in each equation, where you get both sides to equal each other, then that's going to be the solution. That's the point of intersection of those two lines. So what that means, if you put 4 in for x, -1 in for y, and you get a true statement in both equations, that point lies on the graph of both equations, meaning that point is the point of intersection. That's what we're going to do here, is substitute 4 in for x and -1 in for y into that first equation. It's going to be 12 plus 2, that's 14. 14 equals 14, so it's a true statement in the first equation. That means that point lies on that first equation, the graph of the first equation. And then take 4, put that in for x, -1 in for y into the second equation, and see what happens there. So 4 in for x, that would be 8. -1 in for y, that would be -2. 8 minus 2 is 6. It makes a true statement in the second equation. So it makes a true statement in the first and second equations. That means that point lies on the graph of both of those equations. And so since those are both straight lines, that's going to be the point of intersection of those two lines. So the system of equations that has a solution of 4, -1 would be letter A.